Yeah, good morning, students. In the previous classroom discussion topic, we had a discussion on array of structures. Now, in today's classroom discussion topic, we would like to discuss on nested structures as well as the unions. Okay, so now I would like to share my screen. Yeah, so nested structures and unions. Okay, so summary of the previous classroom discussion topic, that is a recap of previous CDT is that. So we had a discussion on array of structures. An array of structures in C programming is a collection of different data type variables grouped together under a single name. So the following example shows the usage of array of structures in C programming. So we declared suppose for example struct book, so which will have int pages, char authors of 30, and then float price. This is a struct book. So here the most common use of structures in C programming is an array of structures. So to declare an array of structures, first the structure must be defined and then the array variable of that type should be defined. For example, we have declared a structure book. Now you want to declare an array B which is of size 10, so which can store all 10 are structure book type variable. So to access every element, we have used that b of 0 dot pages, b of 0 dot author, b of 0 dot price, like that. If you want to access the first book information, we can use like this, b of 0 dot. Similarly, b of 1 dot pages, b of 1 dot author, and so on to access the second book details and so on. That we had discussion in the previous classroom. So by making use of the for loop, we accessed all the variables from the structure, array of structures. Fine. Now coming to this today's topic for discussion is nested structures and unions. So the lecture objectives are, so this session will develop the students' knowledge on nested structures as well as unions in C programming. So the lecture outcome is that after completion of the session, students will able to develop the code in C using nested structures and compare a structure with a union variable. How a structure is different from a union variable, we can able to compare that. Fine. So now we are coming to the nested structure. So C language provides us the feature of nesting one structure within another structure, by using which you can define complex data types. Just like a nesting of loops, okay, we can also define nesting of structures. For example, we may need to store the address of an employee within a structure. So the attribute address may also have the subparts as street, city, state, pin code, like that. So hence, to store the address of the employee, we need to store the address of the employee into a separate structure and nest that structure address into the structure employee. So for example, here if you take it as a struct address, address will have city, house number, pin, and street name. So we are defining a struct employee here, so which will have the data members as int EID, employee ID, char name of 20, then struct address some ADD. So which is an address, which is a member having the data type as a structure address type. So this is what we are calling it as a structure, nested structure. So for example, you can declare here struct employee EMP. Now you can take the employee information from the keyboard, emp.id, emp.name, emp.add.city, employee address.city, emp.add. What we can call it as name, street name, like that. You can use two times here, emp.add.street name. So because of nesting, here we have to make use of two dots. Here we have to use that. Fine. So similarly, when you are trying to print that, you can use emp.add.city, emp.add.pin, emp.add.street name, like that. We can use two dots here to access the member within a nested structure, innermost structure. So there are two ways of nesting of the structures. First method is by separate structure definition. Second method is by embedded structure definition. Separate structure definition here is that we create two separate structures here. Okay, so for example, struct date, which will have dd, yy. These are the three data members. Then we are defining a structure employee, which will have id, employee name, and then dog, date of joining, which is of struct date type. So this is what we are calling it as a separate structures. Okay, as you can see, date of joining is the variable of type date type. Here dog is used as a member in employee structure. In this way, we can use data structure in many structures. So we can use date structure in any structure. We can use that. Not only employee structure, we can use struct date as a member in any other structure also. We can use that. This is one way of nesting. Second method of nesting is that embedding the structure within the structure itself. So for example, you consider an employee structure here. So int id char name of 20, then you are defining struct date within the structure itself, int dd mmyy and dog. So this is a variable of struct date type. Then emp1 is a variable of employee type. So this is a structure we are defining within another structure. This is what we are calling it as embedded structure. So but if you declare embedded structure, so it will not be reused in any other structures. Fine. So that is the reason the first method is more preferable when we are using the nested structures. So the members of the nested structure can be accessed by using the notation as outer structure dot inner structure dot member name. So for example, e1 dot dog dot dd, e1 dot dog dot e1 dot dog dot yy. So like that, here we are using two dots we are using here to refer to the nesting of the structures. Now coming to this reflections part 1, here point out the error in the program. Okay, so struct emp, we have char n of 20 int age. These are the two data members we have. So struct emp e1 is equal to David comma 23 name and age. Struct emp e2 is equal to e1. So we are declaring e2 which is equal to e1. If e1 is equal to e2, print the structures are equal. So can we use this double equal to here assigning of the structure here? So e1 you are assigning to e2. Can we use? So if you are able to identify that, you can able to say that. Okay, so it is not possible to assign one structure to another structure so directly. So what you have to do here is that you have to assign member by member, you have to assign that. So e2 dot name is equal to e1 dot name, e2 dot id is equal to e1 dot id, like that every member by member you have to assign, then only the two structures can be equated. Fine. Then coming to this unions. So union is also a special data type available in C, which is also called it as a derived data type here. So which allows us to store different data type variables in the same memory location. So we can define a union with many members, but only one member can contain a value at any given time. So union provides an efficient way of using the same memory locations for multi-purpose. So in the structure, the memory allocation, if you see that, so already we saw that the memory is allocated for every member of the structure variable separately. But here in the unions, whatever the member which is taking highest memory in the union, that is amount of memory is going to be allocated for the union variable, and the remaining members will share that particular memory or allocated for the union. So the syntax for defining a union will be, we are making use of union keyword, then this is the union name or union tag, and then member definitions we are using as similar to the structure, then one or more union variables you can declare. Fine. So this is what the union declaration, as similar to the structure syntax only. Just in place of struct keyword, we are replacing with the union keyword. But another important thing is that to access the members of a union, we can use this dot operator as similar to that structure member accessing. So union data, data is a union name here. So which we have int I, float f and str of 20. So three data members are there within this union. So how much memory is allocated here for the union? So it is going to allocate which data member is taking maximum amount of memory? str, 20 bytes it is taking. So this is the maximum memory that is allocated for this union data. So this 20 bytes of memory is shared one member at a time. If you are accessing I, if I is using this 20 bytes of memory, then F and str should not be used this memory. If it is trying to use, we are going to get garbage values which is not interpreted properly. Okay. So data dot I equal to 10 means now this memory which is allocated, that is used by I variable. then print data dot I. If you print that, you are going to get 10. Then data dot f is equal to 220.5 means now this 20 bytes of memory is used by this f data member. Fine. So now this f data member data, you can access that. Similarly, string copy of data.str comma c programming. Now this 20 bytes is used by this data member str. Now you can access that. So like this, one member at a time, only this memory which is allocated for the union can be accessed or used. Okay. So simultaneously, for all the data members wanted to use that, you are going to get incorrect result. You are going to get it. Fine. So now coming to this reflections part here, what we are going to do here is that the size of the following union where an int occupies 4 bytes of memory is. So now compute the size of this union demo. So assume that integer is occupying 4 bytes. So integer occupying 4 bytes, float also occupies 4 bytes, then character z array is occupying how many bytes? Because of 10 here, it is going to occupy 10 bytes. What is the size of this union? So the union size is nothing but what is the data member which is occupying maximum memory? 10. So 10 bytes is the memory that is allocated. So instead of union keyword, if you use here struct keyword, now tell me how much memory it is going to be allocated for this structure instead of union. So it is going to allocate how much memory? So it is going to allocate 4 plus 4 plus 10, which is nothing but 18 bytes of memory is going to allocated. In that case structure, it is 18 bytes. In the union case, it is 10 bytes. Fine. So this is what you have to understand, the difference between union and structure. Okay. So the lecture outcomes are revisited here. After completion of this session, students will be able to develop the code in C language using nested structures, as well as students are able to compare a structure from a union. So summary of this today's session is that C language provides us a feature of nesting one structure within another structure, by using which complex data types may be created, and the structures can be nested either by making use of a separate structure definition or by embedding one structure within another structure. A union is a special data type available in C language which allows us to store different data types in the same memory location. So you can define a union with many members, but only one member can contain a value at a given time. So to access the members of a union, we can use this dot operator as similar to the structure. So coming to this lecture level practice problem, so develop a C program to define a student structure with address structure which is nested as a member within the student structure. Okay. So further reading, so if you want to refer the further concepts related to these structures and unions, you can refer this textbook on E. Balaguruswamy, ANSI programming in ANSI C. Okay, chapter 10, you can refer for further readings. Okay, so thank you and all.